I'm here with Chamkaur Ghag, who's a quite well-known professor of physics at University of College London. Would you like to maybe start off by introducing yourself and what you do?
Sure.
As a professionally.
Yeah. So, I'm an astroparticle physicist working on dark matter. So, trying to understand or detect this sort of hypothesized stuff that's out there that actually makes up most of the stuff in the universe. So 85% of everything that's in the universe, of all the matter that's in the universe, is in this form of dark matter. And all of us, all of everything we're made of, from chairs, tables, planets, black holes, all of it only actually makes up about a tiny fraction of what the universe is made of. So we build detectors, very large, highly sensitive sort of radiation detectors effectively, and we put them deep underground. So we're currently working on one called Lux Zeppelin. So I'm the spokesperson of that project, and it's it's located a mile underground under the Black Hills of South Dakota. And the job is really for it to tell us if any dark matter passing through it pings. And if it does ping, and if we do get a signal from dark matter, it'd be the first one ever. And we'd learn a bit more about what the cosmos is made of, what the universe is, at least in the material sense.
So this is kind of like one of the leading edge experiments in the study of dark matter.
Yeah. We are the leading experiment at not finding dark matter. And it's, it took almost 10 years to build it. There's R&D, there's this pre-construction phase, construction phase. You have to screen over 1,000 materials, because anything that goes in that detector anywhere near it has to be radiologically absolutely pristine and clear. To the extent where the center of the detector now is in terms of radiation and purity, it's the cleanest place on or in the planet. It's incredible. This is essentially a laboratory now to look for very faint, very low energy signals that could be coming from the universe, that could be coming from from within our galaxy. And so it's one of the leading experiments. And after 10 years of making it, 10 years of getting it all ready and commissioning it and putting it deep underground and calibrating it and all of that stuff, we ran it for just 60 days of data, and then sort of leapfrogged the previous world leading experiment, the most sensitive ones, to become the most sensitive ourselves. But the really nice thing about it is that was only with 60 days of 1,000 days planned exposure. As in this detector will start to bottom out when we get to about 1,000 days. So we've only just begun. And so the really exciting thing is that we're now into sort of uncharted open water, if you like. It's there's no one has explored this parameter space in the search for dark matter, and we'll be doing that over the next few years. So we could be the ones that finally nail this, or be the ones to say, right, it's not dark matter. It's not this form of dark matter, and the search continues. But it's kind of weird to be at the forefront of this strange sort of quest to understand something we can't see, can't touch, but we think is out.
Right, and you've had a more, I could say, concrete pursuit as well in teaching climate science, also here at UCL.
Yeah.
So it's a bit different subject, obviously, though it's still physical science and nature. How did that come about?
Well, at universities, there's always some moving around and jostling over what we're going to teach and what we'd like to do and what we wouldn't like to do. And sometimes my assumption had always been, when it comes to teaching, I'll be teaching particle physics or instrumentation, the stuff that I do, computing or whatever. But actually, I thought it'd be nice to do something completely different, so I could almost get away from the research and relax over in teaching at some level once the courses were set up. And so I took up environmental physics, something like 12 years ago. And it was a second year undergraduate course. It was only 40 students or so, 40, 45 max. But in preparing for that course, once I took it over and kind of going through the material and then sort of trying to update it, I became more and more educated on the climate crisis. Up to that point, I now know I knew nothing, almost nothing, right? As close to nothing as you can get, really. And then after that, it was just the preparation for the course. It was existential for me. This was at the same sort of time when we're thinking about starting a family and all sorts of stuff going on, new job and lots of stuff happening, and then it's just like, oh, wait, what? This curve goes only one way, and every which way I was looking at it, thinking, I must be. Something about me is getting overly dramatic, surely. Right? If we were this close to extinction at this level, and what this means for food supplies, water, supply chain, just other mammals, full stop. With every page, I was like, can't be, surely not, right? I'm gonna learn that I'm making some huge error, or these notes are, written by some, professor who is just nuts or something, but it was true. Obviously, now it was all true. So the more I was kind of learning about it, the more I was getting into a state of sort of fascination, but fear, anxiety, also this strange sort of exhilaration as well was there as well. And that was coupled with starting a new course and all that kind of stuff, like wanting to do well and teach this course well, and get through the physics of the climate and the environment and all that kind of stuff. But I kind of couldn't wait to get to about the middle of the course where we'd open up into climate change and global warming, because we're sort of leading them and sort of started with essentially building a model of the environment very simply. It's just like, okay, well, here's this rock and we'll have this atmosphere, it'll be made of this and this depth, and we've got the sun doing this over here. What should the temperature be? We'd calculate that, but it isn't, because we've got this atmosphere. Now what? And we move through all these sort of areas until it's like, okay, now we have this stable equilibrium
kind of confident in our physical understanding of the system.
Yeah. And now we'll perturb it.
Right.
And now we'll pump some CO2 in. And what does this do? So it's very good for students themselves to see how easy it is to understand how easy it is to disturb the system, for one thing. But yeah, for me it was very life-changing. I stopped eating meat. I stopped. That led to all kinds of other things as well. Just because I can't be standing in front of these students talking about these are the big contributions, and if somebody were to put their hand up and say, "And what about you?" It's just like, I can't be this hypocrite up there. I felt very uncomfortable as well, even though I felt I'm just kind of giving the information, but it was touching me as a person, much more than me as the lecturer. It's like they're sort of teaching. And yeah, that was sort of the entry into it, and then from then on, it had been getting engaged in sort of UCL's campaigns to sort of go set our targets for net zero and what we're doing around the campus and all that kind of stuff. So I got heavily engaged in all of that stuff.
So you of course understand climate anxiety from a really first person perspective, and particularly without any support, right? In a way that you were basically an isolated person studying this subject, fully capable of understanding it and saying, having a great deal of confidence physically in what it means.
Yeah.
But not really having anybody else around who understood that. So kind of.
No, and feeling like I might be going a bit insane in that why is this not being reported at the level of the seriousness this really is? Because it took, it takes minutes to calculate, what could happen to the Gulf Stream. It's like, all right, well, this much salinity and this much fresh water and this is moving over there, so hang on. And then you look up, the power of the Gulf Stream and you see the decline very, very clearly. It's like, well, let's extend that. And what happens when this happens? It's like, well, if that happens, doesn't Europe go, 5 to 7 degrees cooler like that? Mm-hmm. Surely not. It's like, yes, do it again, yes. Every time the answer is it. So, but why? How are we in this state where there's no outlet, or I'm not reading about this? Or, if and it's very similar to that kind of don't look up type scenario. It's like, why is there? how have I managed to get to this age without hearing that the Gulf Stream could, damn it, turn off with this kind of impact? And that's just one of the things that, I'm sort of studying about, is like permafrost and everything else. And so not having, and then sort of slowly finding, the more I was sort of opening up and sort of speaking about this with colleagues, here in the department, more and more I'd start to sort of sense other people who were also uncomfortable with the lack of open discussion about it, maybe, or sort of try to understand, but what can we do, or what should we do? And then it started to become more apparent that there's a big sort of gradient between those that sort of understand what is going on and potentially, the impact of what's coming, and then those that sort of understand the science but not the impact, and then the none of it, and there's a big sort of divide. But it was quite nice to then find that there were other people that wanted to at least talk about it.
Right.
And so that started to get a bit more comfortable. But the anxiety and the existential crisis sort of stuck around for years, a good couple of years.
Yeah, and so it's kind of something that we're touching, I think, on tension in a way that's at the center of this climate anxiety campaign that we're both working on. In that, it sort of, people don't want to disturb others sometimes by talking about the implication of the science. Yet you can't really be knowledgeable about the physical systems. You can't just investigate them, understand them thoroughly, without coming sort of face to face with what's happening, right? Yeah. So there's this kind of tension between wanting to safeguard students' health, or anybody who learns about its mental health, and then actually just education, full stop, the kind of principles of education.
Yeah. And there are too many students as well that would pick up in those sort of early days on, well, hang on, doesn't that mean this? And I'm like, yeah, it does. It's like, and they're like, are we going to cover that? I'm like, well, it's not really part of the syllabus, but sure, next week I'll prepare something so we can discuss, some of this more. And so, there would be certainly students who would be there, taking in all the information, figuring out how to do the calculations, all that kind of stuff around the atmospheric penetration, all that kind of stuff. But then as soon as, a student or two starts putting their hands up and is asking about the implications, or, well, what does this mean, and what does this imply? That also helped sort of, loosen some, free up some space in that, in the classroom to actually start exploring more deeply. It started to humanize everything a bit more. And I went through a period where, I would, when it came to something like pollution, rather than let's read about this in the textbook, put the textbook down, open up the windows and take a good lungful of, the air right next to Euston Road. And now let's calculate what you just breathed in. Right? And that had a much more, I don't think any of them will forget how to calculate what they're breathing in. Right? And the goal of that was really to try and bring it into, take it out of the abstract nature of, what we're dealing with is this planet with an atmosphere out there, this sort of spherical cow model applied to Earth for a physicist. It's like, no, it's here. This is the air we're talking about. You're breathing it in, and so that worked really well. Was and again, it got more of the students sort of almost embodied, is what I felt like was happening here. Right? They're getting more and more into their seats. Right? They're not just headily thinking about what they need to remember for exams. They're getting present. They're engaging, and they're listening in a way that isn't the student listening. This is the human listening, and it was great because it was a human talking, right? When we were discussing that, and there would be the knowledge sort of exchange in here are the formula, here are the equations, here's all that, let's calculate all of this stuff, and then the implications of what this means, the climate science, and then the sadness. You know, I don't really know what other word to use, but the sadness would be palpable. You know, there'd be I wouldn't say avoidance as well, but you know, there'd be students that clearly don't quite understand why that student is breaking down or is getting emotional in any way whatsoever.
Did you have that, like students crying?
Oh yeah, especially in the first couple of years. And then I'd think like, am I giving this? Is my sadness, all of this really coming out? But no, because they're already aware. You know, they kind of know, and here it is. They're learning about. It's being reinforced, right? No, it's not just a bad dream.
Mm-hmm.
We're now learning about what it is, how we got here, and the scale of what we would need to do.
So essentially, kind of your sense as well that students are coming in basically knowing that, basically in some level knowing about what they're about to learn about, and then the class is a way of, well, during the class they basically find out, it's real.
Yeah.
You know, what I kind of knew about it, sort of like, okay, it just becomes really part of their lived experience and instead of the back of their mind.
Yeah, and I think a lot of them were kind of motivated to come and do this course in the first place because of that. We had, most of the courses that I've taught or been involved in any way have been physics students of various guys, astrophysicists or this physicist or whatever. Mm-hmm. But here we had arts and science students were able to come and take this course as well. And the arts and science students were so much more engaged, and they would, they've made more of a choice to take this course, I think, than some of the other students had, where it may have been convenient or it's maybe it's seen as an easy course or who knows what was going on. But the impact of some of the arts and science students in there and their felt emotion and just be it limbic resonance or whatever was going on here. But then the other students would also then open up to this, or they'd get curious about what is happening over there, and like looking at the screen again, it's like, what? Hang on, wait, what? And slowly they're getting curious as well as to what is happening. And a few years of doing this, I started to, I think, find a way to have it more sort of homogenized so that we could take all the students on the journey at a similar time, bar some of the sort of outliers. And then it would be sort of a mass sort of learning of the equations and everything, and then a mass sadness and a mass sort of, allow the anxiety to be there actually. Right. And then there would be, and this is over the course of weeks, right? But it would be a case of when we're just going to stop there. And it is, sad and everything, but, for this point, we're going to hold off and just be rational scientists. But at this point, you can't. We've actually got to let this in, and through us. And as the students did that, or what aided that was then, okay, so now what are we going to do about it? It felt like sort of, here's some education, then there's this sort of crash, and then there was this sort of up, rise again, that then went much higher than where they started with, in terms of enthusiasm for the job at hand. Almost to the level of, well, here I am, right? I'm a human, I'm here, had these ideas about what I might want to be or want to do and all that kind of stuff, but actually been handed the job of all jobs, right? If you wanted meaning in life, right, here you go, right? And so it was actually at some level almost then liberating, as the students going. So since then, some of these students are, there's one out in Antarctica, climate stuff, another one's a UN ambassador for climate stuff. They're all that I don't know if they were pivoting into this area, but certainly, the usual, I want to go with this, go over here and do banking, or I want to do this, or whatever. A lot of that was suppressed, and a lot of folk wanted to say, well, I want to go and do a master's or a PhD in earth sciences, or climate modelling, or statistics, or energy, or, there's just so many areas where everyone could find something to do, and that for me was quite fascinating, actually. Mm-hmm. As this, be it food, water, energy, social care, anxiety, medical, is like, take your pick.
You must know a lot of students who learn about both dark matter and climate. Do they? So that it's obviously super fascinating area, dark matter. Yeah. What do they choose one of those two generally if they know both of them, or?
Well, I mean, most of the students that do dark matter with me are PhD students, so
Right.
so they've sort of already got locked into their research project. But then as soon as they're here, in fact, even in the interviewing process, I'll try and probe, where are you on climate and things, because we as a group want to do more, but also sort of recognizing the platform, right, that we have. Okay, there's the dark matter and the LZ and the most sensitive dark matter experiments and all that kind of stuff. But that's a great place from which to have excellent students, like really, really excellent students, over the course of a few years, start to see how they can almost start to see their role also in that bigger picture of the world, right? Yeah, there's a very nuanced focus, let's find dark matter, but there's also the scientists who could be educating others, could be getting involved in all sorts of other ways. And that want to do more has grown and grown and grown. So they can still be very focused on the dark matter set, on the experimental physics, but then we're sort of growing as a group in terms of other change that we can do. But then other students, some of the undergraduates would just be, well, what I wanted to do was a PhD in this. Now I don't care, I'm doing this. Or some great PhDs or postdocs would be like, all right, well, we've been doing this in dark matter for a few years, but I'm off to work with that company, a new startup in climate, or this one that's doing carbon sequestration, whatever. And we've from one perspective, we've lost quite a few really good people to that. But from the other side, it's like, no, we haven't lost.
Right.
So that's a big win, I think, right? And so having, and that'll probably increase more and more.
Yeah, well, I mean, and this brings up a question, right? So, I mean, there's this kind of worry in climate education, climate communication, that we don't want to depress people too much, and it comes at the expense sometimes of, as we talked about in the CMP website, of clarity and truth, right? So like we're still talking about 1.5 as alive as a climate goal. Almost no climate scientists believe this. I mean, do you believe 1.5 is alive?
Long gone. I mean, we fluctuated to it this year. We had a 1.5. I remember, a paper a couple of years ago that said, there's a 50% probability we fluctuate to 1.5 in the next, I think it was 5 years. And here we were like 18 months later and we've already done it. And this was in my early sort of learning about it. The bit that would really make me question myself a lot would be, but hang on, my projections say this is a lot worse than what is coming out from this paper. But all right, particle physicists, maybe I shouldn't be looking at this and scrutinizing it too much. Maybe there's some statistical techniques or whatever that they're using that mean that actually it's not as bad as what I'm projecting here, but I could never quite figure it out. It's like, why? What do you mean? Well, what about here will do? Even how quickly we would approach 1.5, I think was really just a presentation issue. For so long, it would be projections of temperature out to 2100, and then we'd talk about what will the temperature be at 2100? Well, temperature will be whatever it is at 2100. Do you know what it's going to be in 2025? Because we might not be able to grow much food in some of these countries, and in 2030, like the impacts and what it actually means on the way to 2100 was being, ignored, I think. And that meant that there was we could play a bit with the numbers because it's out there, it's for the grandkids or something like that. And none of that ever stacked up for me. They'd be like, but this can't be. This is, if this has happened and that's happened and that's happened, well then that's going to happen. It's really not. And eventually the language would come in with feedback loops and all that kind of stuff. It's like, well, actually this means that this will happen and this means that. And I think, come on, don't we know that? Right. Doesn't everyone know that if you have an ice cube, it doesn't melt for a while, but once it starts melting, it's a puddle.
Right.
Very quickly. So these are, I don't know why we needed studies for that.
Right, yeah. And melt rates are non-linear as well.
Yeah. And then the feedback of what that means in terms of the albedo, in terms of, you know, the melt, so much of it. Acidification of the oceans as well was another one, which is just obvious. Right? It's like, well, how do you avoid this happening, right? And what does that mean for the coral? That's easily calculated. I mean, what it means for the humans in terms of where we move and what we're going to do, and whether it's, you know, 1 billion people or 1.5 billion people that are impacted from the fish supplies. Okay, we can talk about that, but that they will be bleached to this percentage by this date was, I think, you know, we could have said that with much more surety than the, you know, we have high probability.
Mm-hmm.
That high probability, so some of that sort of science, statistical language didn't serve humans, I think.
Yeah. So, I mean, there's certain people, maybe we can, James Hansen, obviously, repeatedly, basically correct and pessimistic, and Kelmis, etc. Kevin Anderson, right? There's these few people who seem to be both correct and pessimistic all of the time. You know, so scientific reticence is a huge issue. Do you think that sort of the kind of emotional support that you've started to put in classes? I mean, we spoke earlier about kind of approaching learning about climate as a human issue and letting people be humans and learning together. Do you think that making that type of support part of professional engagement for climate scientists and anybody that really has to learn, even bureaucrats or people who are working in climate NGOs, do you think that type of deliberate emotional engagement and counseling and emotional sharing might be helpful in kind of counteracting some of that tendency to not really put two and two together, basically?
Yeah, I think it'd be helpful. I think it's necessary. It's honestly, you know, the help and the support for the individual to then be able to go and, you know, educate others and hold that. It's almost like you're holding that space, right? For tens of people, 50 people, 100 people. You know, it's the course that I'll be teaching in January is like over 100 people in climate and energy. And we will go through this, no doubt, right? But and in that phase, the support that is sort of needed for anybody trying to I don't know what the word is, I want to say activate, and it does feel like a sort of an activation. It's almost like there's some students who are very, you know, it's not even depressed. It almost sort of, it's like someone's hit you over the head and you've just fallen into a completely nihilistic, you know, sort of landscape where it's just like, oh, this is all rubbish. But it feels, you know, there's still a feeling of not being able to settle, even in that. Right? So even if you do park it and you put it away, the anxiety or the stress around it is still there. It's sort of almost like an unconscious oppression or something like that going on. But as soon as
you can't not know it. You can basically just try not to pay attention.
Exactly.
To it, right.
Exactly. But you can't not know it, and that's right. And I think that, you know, the even at the level of, and I haven't, you know, said this kind of stuff to students, but I thought, you know, if you did want to go for, you know, this is how bad it could get, or things like that, there's plenty of things that can be said that will just be, you know, lots of doom and gloom and things like that. But there's ways of presenting the science that is very clear. But then there just needs to be that pause. Pause, let it sink in, let it be there, and then let the person feel it. Right? If they can feel it, if they are feeling it. Because from there, the activation, if you like, into action, into will, in almost a power. There's like a sort of a power being generated in that group that's coming from individuals where they want to do something, but not so much in let me do something because I'm uncomfortable sort of way that can be out there. You know, I see there's lots of folk that are, you know, I'm doing this, I'm doing that, I'm doing that. So why? Why would that help? That seems very similar to what got us into the mess in the first place. But the sort of taking it in, sitting with that, saying, okay, it's not all on me, but what could I do? Right? Where do my passions lie? And so sort of trying to align individual passion with their own care, you know, with an understanding that this is sort of good for themselves as well. To not just face it, like let it pass through. So whether you face it or not doesn't change it happening.
Right.
But if you do face it and you let it pass through, you might find that, you know, beyond the fear, there's potential just waiting to get cracking. You know, and I think empowering the students with that. I think it's all right to be a human. It's all right not to. You know, it's understood that each of us want to fix everything, you know, just heal it all, fix climate change, and I think so many of us, maybe all of us, think at some point that it's on us as the individual. At least that's what it feels like, and that's what we've got to help them out of. Saying no, it's not. That's not the case. We're all in this. More and more will join. Don't worry about that. They won't have a choice. But for now, we need some early pioneers who aren't as shook. Yeah. Right. When it really does start hitting the fan. Right. Some people who are actually, all right, able to sort of pass on that assurance that it will get bad. Of course, science is telling us it'll get bad, but it's up to us to sort of shorten that as much as possible. And there's so much that can be done. So much that we could. I mean, and that's the thing. Like I say, it's going to get bad. There are pathways where it doesn't really get that bad. Or it doesn't get much worse. Let's say the likelihood that we, you know, suddenly have decentralized solar panels, you know, in a global network. Unlikely that will happen next week, but you're right. It's not unlikely that it would never happen. I find that much more unlikely. So then it's the case, well, let's just get cracking and do it sooner, right?
Yeah, exactly.
There's so many things like that we're going to need desalinate, that we'll need water, we'll need food. How are we going to grow this? And having students actually think about this creatively is so much fun. Like some of it is just absolutely out there, Star Trek level genius creativity. And then my job is like, okay, but what do we do next year, right? How do we get to that? But then other students are very, you know, here and now. Well, would this work? You know, let's start investigating this from domes, Eden Project like domes, you know, to grow. You know,
is there a way of saying that, you know, kind of necessity we always say is the mother of invention, right? And if you think about the fact that most of the people in probably your department aren't really totally, you weren't clear about climate until you took the course, and probably a lot of your colleagues aren't.
Right.
So we have the people most capable of invention not actually knowing that there's a necessity, because essentially we're afraid of scaring people.
Yeah. Yep.
That's more or less where we are. Yeah. Right.
And I think it's not even, I think we're afraid of being like offensive or something. It's almost like, you know, it's could it possibly say something rude? You know, it's a very strange one.
Well, yeah, we're scared. I mean, this is so. I mean, I think what you mentioned. I mean, this is going to be, I think, one of the things in the anxiety campaign that we focus on bringing as CMP, because there's the social science element, right? That people are going to get motivated if they have the facts, if they have, you know, basically what happens is you hear about climate, you have a future that you're imagining, and then you have a new future that somebody just told you about. This is what actually seems to be happening, and there's a difference.
Yeah.
And when you have a difference between what you have been imagining and what you're being told, then there's usually an emotional response.
Yeah.
Fear of losing your future, fear or anxiety, a depression if you just give it, if you say, well, actually, okay, that's got to be the way it is, and that's sort of depressing.
Yeah.
You're then just living in the horrible climate future where we do nothing. Yeah. Or else there's a kind of denial where you as you say, just try not to know. So we have this difference, but try not to attend to it.
Yeah.
Still, I've got this kind of anxiety at the fringe of awareness is what James would have called it. Fringe consciousness of anxiety, but you can't really get rid of it. Right. So that's where we're at choice-wise, and for people to start to get into action, it's kind of like you have this anxiety, that's energy that can be turned into motivation, right? So knowing that something's at stake is potentially hugely motivating if you believe that you can do something as part of a response. And so then you have to have an action. So there's kind of like knowing the truth, having people to hear it with, because you get this overwhelm. All of those emotions we just mentioned are overwhelming.
Yeah.
So having some other people to hear it with, to bring down your level of arousal. When people hear things together, they tend to be calmer. Then having something to do with them, that feeling that as you mentioned, everybody else is going to play their part. A kind of, you could say, a faith, like an evidence-based faith.
Yeah.
Churchill would say what solid grounds on which to build hope. Hope can be built on solid and reasonable grounds. That more people are going to find out about this and start doing their part as well. And that fourth, what we call the fourth strand, is this kind of sense of being part of something larger, is precisely what no one does in the science experiments that psychologists run when they're exposing people to climate messages. No one says, okay, there's this really serious problem, and there's a movement that's joining that is recognized, that is forming, that's recognized our institutions aren't up to the task, and people are organizing, and essentially they're going to challenge politics and do everything they can, people from across professions, to change the way business as usual works. And it's getting to be a large percentage of the population, with more and more influential people from inside government, from inside huge corporations, inside academia, etc. And if you hear that, that's totally different, right? It's not you alone knowing about climate change and being one of some billions of people who can't do anything, but that's not the story that's being told, right?
No. Yeah, and having even at the level, the very first action that some of these students would do would be that sort of pass on the education, pass on the knowledge, and going home and talking to family. It's sort of like an immediate, that energy was turning into kinetic energy almost immediately, which was amazing. Even if and so it was scientists behaving like scientists, right? Spreading the science, spreading the what's understood here, and that learning more and more that there's so much going on, and that they're joining or becoming part of the greatest challenge there's ever been. I think is actually. There can be sort of, I don't want to say the word excitement, but it almost says there can be excitement there as well. It's sort of, here's the opportunity to change all of the crap. So, so much of the nonsense that we've done, from wars or subjugation in so many areas, so many sort of parts of society over so many centuries, here's how we end it, right? The climate change is now affecting the whole planet. We have to cohere. We have to cohere as one species and recognize that it's on us to look after the other species that we depend on, right? Even at the very selfish level. It's like, get compassionate if you're selfish, because this is and that it's in human civilization, so we've had nothing like this. There have been pockets of stuff, but nothing that threatens the whole. And if the whole is threatened, does the whole respond as one? And if the whole can respond as one, what can't we sort out? From hunger to poverty to our resource allocation to distribution, that's a complete game changer for me. And so that's it might be a naive hope, or it might be but I really don't see how we get to. So even at the level of countries now saying, I saw an article, I just read sort of the first few lines, some new fund or whatever that's coming into. That was it. It was a union of concerned scientists who had an article, or I got an email, and I didn't read all of it. And normally I love a lot of the stuff they put out. I think, all right, that's good, concerned scientists. But it was it spoke about the economic benefit of taking a leading role. Whilst individual countries are still thinking about the economic benefit to them from climate leadership, you're still in the old paradigm, right? This is not share people,
right?
It's not going to be about, hey, we survived climate change with the most money, so I don't think you understand the science then.
Yeah, I think this is right. This is part of this just hasn't sunk in. If that's still the level we're still talking about it, what's at stake is not sunk in, right? And I mean, this is in your experience. I mean, of people that you meet, you think if you really let it sink in, do people think that way anymore? If they
when it really sinks in,
no.
Then it evaporates almost immediately. It's like, well, how could we? What does it mean to have sort of economic might over some other country? If you're so dependent on a redistributed supply chain, right? Be it the materials, be it the water, be it the food, however this is going to work, a single country either enslaves the rest of the world, or we work together, right? And then even the very notion, I mean, this is getting even more out there, but to me it seems kind of obvious that the ideas of kind of national, if we had energy sharing through a distributed wind and solar system, we don't need batteries,
right?
Because the sun's always shining somewhere, and in an hour you get all of humans' energy needs from the sun. An hour, right? Of course, we don't capture all of that sunlight. Maybe we capture
that for the year.
For the year, yeah. At the moment, 82% of all of our energy for the year comes from fossil fuels, and we could get all of the sun gives back to the earth in about 67 minutes. It's absurd. But then we're not catching all of that. So let's say we catch 100th of it. All right, so 100 hours. Let's say we catch 1,000th of it. All right, so 1,000 hours. This is not a big deal.
And realistically, it's like 25%. So that's the efficiency of solar panels, right? So,
But even if you factor that in, the number of hours in a year is still far greater.
Oh, it's actually 25% efficient. So you're saying it's basically 4 hours if you had the whole Earth's surface covered in solar panels. However, if you can cover 1% of it.
State of Nevada. And we're done.
Right.
And the point is, if you then have them decentralized, if they're all over the planet and they're hooked up, you don't need batteries,
right?
Because the sun's always shining, right? And it's like, well, what about all the losses in the cables? What about them? We have them now. Right? Have as much loss as you like. The sun gives a lot of energy. But what does it mean for a city like Amritsar in India to then have cable going across into Pakistan, sharing that energy? What does it even mean now, right? For this country's power, when you're sharing your power. So that whole business of national kind of boundaries and all that kind of stuff, it starts to get quite tenuous. I think then we're sort of almost back to, folk over there like that kind of food and like dressing like that, and they like this kind of music, and folk over there like this and this and this. But the whole notion of my country must go and doesn't exist. Everything is. It already doesn't exist with the supply chains and everything like that. We're so interdependent, but this one will bring it. Climate change brings it home in a way that I don't think anybody can deny.
It's probably the intertwined nature is more viscerally clear than ever before. Should we? Let's.
Maybe one more question if there is.
Maybe. Let me see if there's. Truth versus health. No, I think we've got all the ones that we had in here. Well, the only thing actually we didn't mention was about kind of, can you say something about you being a spokesman for the dark matter experiment? Is that in some way, do you feel it gives you more of a platform to talk about climate, or more of a chance to make an impact? And does that even affect your your kind of enthusiasm for the job?
Yeah, no, it does. I mean, it definitely gives a platform to sort of speak about it in places where it wouldn't be spoken about otherwise. And just yesterday I was giving a talk at the University of Liverpool on dark matter, and in the middle of it I sort of show an image and say, of course, here's this person, looking out at the cosmos, but they're kneeling on the ground, right? You need an earth to do dark matter studies, right? And then kind of went back to the dark matter, talking about sort of sustainability in the field, and then getting more and more people comfortable hearing about it and speaking about it feels like good work to me every time folk want to talk about it afterwards. Mm-hmm. And so it's great that you said that, or it's like, all right, good, now go pass it on, right? Everybody, all physicists. And so even within LZ, it's a collaboration of some 250 people. We had an analysis workshop here at UCL just a couple of weeks ago, and so we tried to, we enforced just low carbon food for the whole meeting, and the sort of workshop dinner that we had as well. And some departments have been doing this kind of stuff already. We haven't. So just starting to do it and getting people more and more used to this is great, because we've got a lot of people with a lot of skills amongst that 250, and there's students sort of coming and going. So it's like it's the steady state is 250, but there's many more that kind of move through it. And if we can test how we work together in lots of different areas of the project, and how we can sort of cohere to common goals, even though we're very different and we argue about how we're going to get there. I think it's a great sort of environment with which to test these kinds of ideas.
Mm-hmm. That's amazing.
How we collaborate, how we work together, how we schedule things, all of that jazz.
So one more question, actually, which is, one thing that really strikes me is that people who who's done their 10,000 hours of physics, right? Kind of this thing of the 10,000 hour rule, where to really wrap your mind around something difficult, have an ability to imagine and feel the reality of a changing climate. I think from looking at equations, there's always this problem that the average person can notice that the weather's changing, the kind of non-linearity of things is not as easy for them to touch imaginatively. Whereas people who really deeply understand physical systems they don't have a choice if they know. I think they have less of a choice to deny it in a way. And so, I think the question is, isn't it almost incumbent on physical scientists to be human? Because nobody can imagine the climate in this human a way, can experience the climate future, as well as somebody who has learned to condition their imagination on physical systems, to imagine physical systems with great lucidity. And so if anybody is to communicate the consequences of a changing climate, physical scientists almost seem to have to play a role. Do you think that's...
Yeah, no, I completely agree. The climate change, when I was first learning about climate change, what would run through my head would essentially just be Monte Carlos and simulations. This is what I've been doing as a physicist for many, many years. You build a detector in the simulation in the computer, and then I find this. Like that, run 1 million different runs of different configurations to see what's likely to happen. And then eventually, start to realize that, I'm just using a computer to do what I think most physicists are doing all the time. These kind of projections and, is this a logarithmic, is this linear, is this whatever? How is this going to change if we do this and whether we do that? And so you just have to be shown or see the first few data points. And that's it. As a physicist or a physical scientist, it's like the training or it's not even the training, the innate part of us that likes analysing the data and looking at the repercussions of all of that. What does this actually imply?
Well, it's also the confidence to kind of say, I just did this calculation and I'm quite sure that I know how to do this.
Yeah.
Right?
Yeah.
And so that means, what the fuck, basically, right?
Yeah. But then sharing that with people and or discussing it with other physical scientists. I mean, often there's also the disembodied aspect of what we do, which is so much of not human, just living in my prefrontal cortex, just, I live in thought, I am thought. And so it's the thought part can do away with that data easily as well, just like I might read a paper and okay, park that. So this part is very good at, denying the implications or not wanting to look further. Mm-hmm. It's all well and good to say, it could be 1.5, 1.7, what's the difference? 2 degrees, to a lot of folk. And some people have said, well, it'd be lovely, if this planet was 2 degrees, what is that?
It's not Tyrannius.
Yeah, I'm not sure it would be, but this is, the actual, the implications of it, right, are the terrifying part. And it's physical scientists or scientists in general can be good at gobbling up the data, doing the analysis, doing the projections, and then stop there, right? Without then letting it come back down and say, hey, your young child may never see a tiger, right? Or certainly their children may, the rate of loss of mammals or the rate of loss of this. Like if I just list out all the things that you take for granted that your kid or grandkids certainly may never see, right? Like, or anything like that. I mean, that's just one sort of weird example, but for me, that's very stressful. Mm-hmm. Yeah, it does something that I can sense inside my body. It's not just a graph, right? This is the loss of species is I mean, maybe again limbic resonance with all mammals, I guess, at some level, right? And it's harder for them to live on this planet than it has been for a long, long time. Mm-hmm. And for me, by extension, it is for us as well. We're not out of that system. Mm-hmm. And so, yeah, scientists having confidence. I think it's almost maybe an inverse imposter syndrome. Like, once you come into the science, it's like, oh my God, all these illustrious scientists, who am I? It takes a bit of time to see that, oh, okay, I can do stuff that they respect and value. Okay, maybe I'm not such an imposter. Or we all are, it's fine. But then the taking the science and coming out and speaking to the public in a way that is truthful, as in, I'm not talking to the public to plug, dark matter and get everyone confused so that they can read this magazine or whatever like that. Coming out and just speaking about the truth of the situation we're in and what the implications are and then what could happen. That, I mean, I can imagine many scientists who, if asked to do that, would feel that imposter syndrome. Like, who am I to do that? This isn't my job. Which we just got to break out of. And that's just a thought. That's a mindset that is utterly untrue. Like, a scientist's job is not to go out there and speak science. I mean, who told you that?
Right.
But it's just not been done so much in the past. It's been sort of, we'll be these objective, unbiased things that live over here and just analyse the data or whatever. It's like that. Not when I'm breathing the same air and it's the temperature on my body. It's like, is climate change not affecting you then over there?
Right.
And at some level, they don't know that it is, I guess. And that's the sort of the job of the education, I guess, even amongst peers and colleagues.
Right. Yeah. Okay. Great.